Welcome to the final phase of our data analysis course. In this comprehensive journey, we'll guide you through the essential skills every data analyst needs, from feature engineering and data scaling to machine learning and building your professional portfolio. Whether you're looking to land your first job or sharpen your analytical toolkit, this course is designed to give you practical, real-world skills. Let's start by understanding the roadmap ahead and how each module will build your expertise step by step. Feature engineering is a foundational skill in data analysis and machine learning. It involves creating new columns, transforming existing data, and extracting meaningful information from raw datasets. For example, you might convert text categories into numbers or extract the year and month from a date column. These steps help your models understand the data better and often lead to improved accuracy. Throughout this section, we'll explore why thoughtful feature engineering can make or break your analysis. One of the simplest yet most powerful techniques in feature engineering is creating new columns. By combining or transforming existing data, you can uncover hidden patterns. For instance, if you have a dataset with sales and costs, you can create a new column for profit. Or if you have a date column, you can extract the day of the week to see if it impacts sales. These new features often provide valuable insights and boost model performance. Any machine learning algorithms require numerical input, so converting categorical data into numbers is essential. This process, known as encoding, can be as simple as assigning numbers to categories or using techniques like one-hot encoding. For example, if you have a column for color with values like red, blue, and green, you can represent them as 0, 1, and 2, or create separate columns for each color. Proper encoding ensures your models can interpret and leverage categorical information effectively. Dates often contain valuable information that can be extracted to enhance your analysis. By pulling out the year, month, or even the day of the week from a date column, you can identify seasonal trends or patterns over time. For example, sales might spike during certain months or drop on weekends. Extracting these features allows your models to capture temporal effects and make more accurate predictions. Quality and relevance of your features directly impact your model's accuracy. Well-engineered features help algorithms uncover relationships within the data that might otherwise go unnoticed. By thoughtfully selecting and creating features, you provide your model with the context it needs to make better predictions. This is why feature engineering is often considered more important than the choice of algorithm itself. Data scaling and normalization are crucial steps in preparing your data for machine learning. These techniques ensure that all features contribute equally to the model, preventing any single feature from dominating due to its scale. For example, if one column ranges from 1 to 1000 and another from 0 to 1, scaling brings them to a comparable range. This step is especially important for algorithms that rely on distance calculations, like k-nearest neighbors or clustering. Max scaling is a popular normalization technique that rescales data to a fixed range, usually 0 to 1. This method subtracts the minimum value and divides by the range, ensuring all values fit within the specified bounds. Min-max scaling is simple and effective, especially when you want to preserve the original distribution of your data. It's widely used in preprocessing pipelines for machine learning models. Standardization transforms your data so that it has a mean of 0 and a standard deviation of 1. This is particularly useful when your data contains outliers or when features have different units. Standardization is commonly used in algorithms like logistic regression and support vector machines, where the scale of input features can significantly impact performance. Scaling your data is essential for many machine learning algorithms to function correctly. Without scaling, features with larger ranges can overshadow others, leading to biased models. Proper scaling ensures that each feature contributes equally, resulting in more accurate and reliable predictions. It's a simple step that can make a big difference in your model's performance. Standard Scaler is a popular tool in Python's scikit-learn library for standardizing features. It automatically calculates the mean and standard deviation of each feature and transforms the data accordingly. Using Standard Scaler is straightforward and integrates seamlessly into your machine learning workflow, ensuring your models receive properly scaled input. Machine learning, ML, is a branch of artificial intelligence that enables computers to learn from data and make predictions or decisions without being explicitly programmed. ML is transforming industries by automating tasks, uncovering patterns, and providing actionable insights. In this section, we'll explore what machine learning is, its main types, and how it's applied in the real world. Its core, machine learning is about building systems that can automatically learn and improve from experience. Instead of following static instructions, ML models analyze data, identify patterns, and make predictions. This capability is what powers recommendation engines, fraud detection systems, and even self-driving cars. Understanding the basics of ML opens up a world of possibilities for data-driven decision-making. Machine learning can be broadly categorized into supervised and unsupervised learning. In supervised learning, models are trained on labeled data, meaning the correct answers are provided during training. This is used for tasks like classification and regression. Unsupervised learning, on the other hand, deals with unlabeled data and aims to find hidden patterns or groupings. Clustering and dimensionality reduction are common unsupervised techniques. Machine learning is everywhere in our daily lives. From spam filters in your email to personalized recommendations on streaming platforms, ML models are working behind the scenes. Other examples include credit scoring, image recognition, and language translation. These applications showcase the versatility and power of machine learning across industries. Linear regression is one of the simplest and most widely used algorithms in machine learning. It's used to predict a continuous value, such as sales or prices, based on input features. By fitting a straight line to the data, linear regression models the relationship between variables and helps you make informed predictions. Regression is a statistical method used to estimate the relationship between variables. In data analysis, regression helps you understand how changes in one variable affect another. For example, you might use regression to predict house prices based on features like size, location, and age. This technique is fundamental for forecasting and trend analysis. One of the most common applications of linear regression is predicting sales or prices. By analyzing historical data, you can build a model that forecasts future values based on key features. This is invaluable for businesses looking to optimize inventory, set prices, or plan marketing strategies. Accurate predictions can lead to better decision-making and increased profitability. Let's consider a simple regression example, predicting house prices based on square footage. By plotting the data and fitting a line, you can see how price increases with size. This straightforward approach demonstrates the power of regression in uncovering relationships and making predictions, even with just one feature. Classification is another core task in machine learning, used to assign data points to predefined categories. Unlike regression, which predicts continuous values, classification deals with discrete labels. Common examples include spam detection, image recognition, and medical diagnosis. Understanding classification is essential for tackling a wide range of real-world problems. Classification involves predicting which category or class a new data point belongs to. For example, an email can be classified as spam or not spam. This process relies on learning from labeled examples and applying that knowledge to unseen data. Classification is a fundamental concept in supervised learning and underpins many practical applications. Classification problems can be binary with only two possible outcomes or multiclass with more than two categories. For instance, spam detection is a binary problem, while classifying animals and images could be multiclass. Understanding the difference helps you choose the right algorithms and evaluation metrics for your task. Spam detection is a classic example of binary classification. By analyzing features like email content, sender, and frequency, a model can learn to distinguish between spam and legitimate messages. This application highlights the practical value of classification in improving user experience and security. Evaluating your machine learning models is critical to understanding their performance. Key metrics include accuracy, precision, recall, and the confusion matrix. Each metric provides different insights into how well your model is performing and where it might need improvement. In this section, we'll break down these concepts and show you how to interpret them. Accuracy measures the proportion of correct predictions made by your model. It's a straightforward metric but can be misleading if your data is imbalanced. For example, if 95% of emails are not spam, a model that always predicts not spam will have high accuracy but poor usefulness. That's why it's important to consider other metrics as well. Precision focuses on the quality of positive predictions. It tells you what proportion of predicted positives are actually correct. High precision means that when your model predicts a positive outcome, it's usually right. This is especially important in scenarios where false positives are costly, such as medical diagnoses. Recall measures the ability of your model to find all relevant cases within a dataset. It's the proportion of actual positives that are correctly identified. High recall is crucial when missing a positive case is more serious than a false alarm, such as in disease screening or fraud detection. Confusion matrix is a table that summarizes the performance of a classification model. It shows the counts of true positives, true negatives, false positives, and false negatives. By analyzing the confusion matrix, you can gain deeper insights into where your model is making mistakes and how to improve it. Splitting your data into training and testing sets is a best practice in machine learning. The training set is used to build the model, while the test set evaluates its performance on unseen data. This approach helps you gauge how well your model will generalize to new situations and avoid overfitting. Splitting data is crucial because it prevents your model from simply memorizing the training data. By evaluating on a separate test set, you can detect overfitting and ensure your model performs well on new, real-world data. This practice is fundamental for building robust and reliable machine learning solutions. Overfitting occurs when a model learns the training data too well, capturing noise instead of the underlying pattern. This leads to poor performance on new data. By splitting your data and using techniques like cross-validation, you can detect and prevent overfitting, ensuring your models are both accurate and generalizable. Common practice is to split your data using the 80-20 rule, 80% for training and 20% for testing. This balance provides enough data for the model to learn while reserving a meaningful portion for evaluation. Adjusting this ratio may be necessary for very large or small datasets, but the principle remains the same. Dashboards are powerful tools for visualizing and communicating data insights. Power BI and Tableau are two of the most popular platforms for building interactive dashboards. In this section, we'll cover the basics of importing data, creating charts, and designing dashboards that help stakeholders make informed decisions. The first step in dashboard creation is importing your data. Both Power BI and Tableau support a wide range of data sources, from Excel files to cloud databases. Ensuring your data is clean and well-structured at this stage sets the foundation for effective analysis and visualization. Charts are the building blocks of any dashboard. Power BI and Tableau offer a variety of chart types from bar graphs to scatter plots. Choosing the right chart for your data helps you highlight key insights and trends, making your dashboard both informative and visually appealing. Interactivity is what sets modern dashboards apart. Features like filters, drill downs, and dynamic visuals allow users to explore data from different angles. By building interactive dashboards, you empower stakeholders to answer their own questions and gain deeper insights from the data. Let's walk through a real data analysis project from start to finish. We'll begin by loading a dataset, then move on to cleaning the data, performing exploratory data analysis, EDA, visualizing key findings, and drawing actionable insights. This hands-on approach will help you see how all the concepts fit together in practice. The first step in any project is loading your dataset. Whether you're working with CSV files, databases, or APIs, it's important to ensure your data is imported correctly. This step sets the stage for all subsequent analysis and helps you avoid issues down the line. Data cleaning is a critical step that involves handling missing values, correcting errors, and ensuring consistency. Clean data leads to more reliable analysis and better model performance. Techniques include removing duplicates, filling in missing values, and standardizing formats. EDA is the process of exploring your data to uncover patterns, trends, and anomalies. This involves generating summary statistics, visualizing distributions, and identifying relationships between variables. EDA helps you form hypotheses and guides your next steps in the analysis. Visualization is key to communicating your findings. Using charts, graphs, and dashboards, you can make complex data accessible and actionable. Effective visualization highlights important trends and supports data-driven decision-making. The ultimate goal of data analysis is to extract actionable insights. By interpreting your findings, you can make recommendations, identify opportunities, and solve business problems. This step transforms raw data into real value for organizations. Building a strong resume and portfolio is essential for launching your data analyst career. Highlight your projects, showcase your skills, and present your work in a way that stands out to employers. In this section, we'll share tips for creating a compelling resume and portfolio that open doors to new opportunities. Projects are the best way to demonstrate your skills to potential employers. Include detailed descriptions of your data analysis projects, the tools you used, and the impact of your work. This gives recruiters concrete evidence of your abilities and sets you apart from other candidates. A polished GitHub profile and LinkedIn presence are invaluable for data analysts. Share your code, document your projects, and connect with professionals in the field. These platforms help you build your personal brand and attract job opportunities. Your portfolio should showcase a variety of projects that demonstrate your range of skills. Include clear explanations, visualizations, and links to your code. A well-organized portfolio not only impresses employers but also helps you reflect on your growth as a data analyst. Embarking on a data analyst career requires a mix of technical and soft skills. In this final section, we'll outline the key skills you need, salary expectations, and tips for interview preparation. With a clear roadmap, you'll be ready to take the next step in your data analysis journey. To succeed as a data analyst, you'll need proficiency in data manipulation, statistical analysis, and data visualization. Familiarity with tools like Excel, SQL, Python, and dashboard platforms is also important. Equally valuable are communication skills, problem-solving abilities, and a curiosity for uncovering insights. Data analyst salaries vary based on experience, location, and industry. Entry-level analysts can expect competitive starting salaries with significant growth potential as you gain experience and specialize. Staying updated with the latest tools and techniques can further boost your earning potential. Preparing for data analyst interviews involves reviewing technical concepts, practicing problem-solving, and showcasing your portfolio. Be ready to discuss your projects, explain your analytical approach, and demonstrate your communication skills. Confidence and preparation are key to landing your dream job. As you complete this course, you now have a clear roadmap for building a successful data analyst career. Continue learning, apply your skills to real projects, and keep refining your portfolio. With dedication and curiosity, you'll be well equipped to thrive in the dynamic world of data analysis.